So let me show you this. Let's put this in focus. So this is a Hailo8L module mounted with the M2 hat on the top of Raspberry Pi 5. So, and actually this is a camera, this is a PiCam version 3. It's a 12 megapixel camera. And what we are going to do today with the Raspberry Pi 5 is, with nerves, we are going to run YOLO models on using the Hailo8. Which means you can run these models with this device. You can run with this module. You can run object detection model, even large object detection models on a Raspberry Pi in real time, and obviously on nerves. So my module is the 8L, which, even if it is the second one, the 8 is faster. The 8L is 13 tops, and 8 is 26 tops. So yeah, so you need a Raspberry Pi 5 because you need this port here, which is a PCIe port, and then for example, here, this version, I don't have this version. You see that it's a hat, it's all embedded. I have the M2 hat plus the Hailo module. Actually, this is the faster version. You see 26 stops, so probably this is 8. And this is the 8L, I think. The reason why I'm thinking is because I saw somewhere 13 tops, maybe here. But yeah, it's important to understand which model we have because we then need to compile and get the right model, the right compile model for the right module. So today we are not compiling any model. This is going to be for sure another video because it takes time and effort, definitely, to compile a model. But here, so we are going to, so the YOLO Ultralytics and many other models are available here. I'm going to, you will find these links in the description of this video below. And but yeah, you have many models and they're already compiled to what is their format, the Hailo format, HEF. And then we are going to see, so we are going to see the Ultralytics YOLO, classic, on the classic 80 categories. And then we are also going to see how to run our own custom model. It's already compiled, as I said, it's already compiled. It's the YOLOv8 to detect the plates. And you can see the other video to see how to, it should be the last video where I shown how to fine-tune a YOLOv8 model and use a public plates dataset to fine-tune this model to run object detection to detect plates. So, and obviously we are using nerves, and we will compile our firmware and run it on this device and see what happens. And I will use still images because right now I have some issues with the camera, but maybe in the future I will run a real on-road video running these models on this device. So we are going to use an NxHailo, and this is the NIF. So this is the Elixir library we are using we will use to interface to run our models. So this library is made by Vittoria Biton and Paolo Valente. The thing is, this is actually can be used as a firmware. So we start by cloning this repo. Okay, again, you find this link in the description below. Okay, let's clone the repo. And we stay with the main branch. Let me open here with code. Okay. So yeah, we're going to use this directory. So actually what I can do is to jump into that directory. Okay. Code. All right. So the cool thing is when compiling this, it's going to download under priv. It's going to automatically download the YOLOv8M, I think. I don't remember where exactly is the code, where this happens. I think here, you see, download YOLOv8 model. So it's going to download the compiled model and yeah, and also the classes. But if you want to try different models, under here you see that under this repo, which is the official one, you will find, like, for example, under object detection, even segmentation, you have, well, the cool thing is that for that device here, you see how many frame per second you can get. So benchmark, you have benchmark on the accuracy and on the frame per second, so speed, even with batches. And we are going to use, actually I'm going to use the YOLO8M, the NX, that this code downloads automatically, which is, I think it should be 8M. It's not here. Yeah, it's this one. I think it's this one. And it should run at 50 frames per second in real time, because it's we don't batch. But in batches it runs at 87. Consider that these models are quantized, so this is the mean average precision, is this one, which is compared to the original. I mean, this is MAP 5095. So I think this is the, I don't know if this is a mean average precision with an IOU of 50. So this is, I don't know if this is MAP 50 or MAP 5095. But yeah, so let's now focus on how to run this model. So we don't need to download it because the code will download it automatically. Yeah, so let's start from this. And first, we need to, here we have this script we need to load. So the target is Hailo Raspberry Pi 5. Let me see in mix, actually, the target. So RPi5. Yeah, so what I'm going to do is to first edit this. Should be, okay, so this mix target should be Raspberry Pi 5, and I leave the remaining environment variables, so vision precompiled true, XLA force through build false, okay. And then source, okay. So first let's get the dependencies. Great. And remember in target to set the the Wi-Fi. I'm going to use the Wi-Fi to connect via SSH to the device. So remember to set this. Okay, and now we're going to build the firmware. Firmware. Okay, so let's start from scratch. I will flash the firmware into the micro SD. All right, mix, burn. Yes. And as you can see here, we find in priv. The important thing is that here we find the YOLOv8 that has been downloaded by mix. I mean by this function here, and the YOLO8 classes. The JSON inside here you find a list of classes. Okay, let's plug this. Actually, I'm going to remove the camera because we are not going to need it right now. And I'm going to plug it to power it on. Okay, we should be able to connect to our nerves device. Great. And we see that we have our NxHailo library and the model. So let me grab Hailo. You see that the module is detected correctly. Should be detected correctly. Firmware loaded. Okay. We're not going to work using IEX. We are going to use Livebook, and hopefully there is a trick I found. So Lars, I've seen Lars suggested this, and also you can find it in the NxHailo Livebooks remote device inference. You see here. We're going to follow most of these Livebooks, but you see this is a trick to run the to start EPMD on our device and connect using our local live view. Let's see. So we have this. Actually, I'm going to follow this and let's start. So what is this? It's the host name. See? Okay. So this host name will be assigned to the node host name. Okay. And then set the cookie. In this case, my cookie is fine. All right. Then we can actually disconnect and run Livebook server locally on my computer. Okay. So we need to connect to the node, and so we need to disconnect and connect to attach to the Raspberry Pi nerves. So remember, so the host name is this one, and the cookie is my cookie, the super secure cookie. Connect. Okay, so we are connected to the node. Let's start. So first, remember that our models are in here in the priv directory, okay, of the NxHailo application firmware priv directory. Okay. Let me see what we have here. you see that we need to load this file here. And let's go a little bit deeper in what we have here. So NxHailo, actually it's NxHailo inside Hailo, I think. We have, yeah, you see here the load. So it's NxHailo. We have the load, and we pass the path, and this loads the model using the NIF. So the library does everything for us, and so here NxHailo it's NxHailo load and path. So priv, and actually this is a string, priv, and YOLOv8 it's 8M HEF, okay, and this should return okay, and Hailo model. Okay, fantastic. So something to notice, the important part here is inside pipeline we have input with stream, output with stream. So here is the shape of the input. So this is for to quantize the input. For this model, we don't need to think about this, but for YOLOx, we need this. And also quantize output. There is no, I mean, we don't need to dequantize ourselves the output. And the cool thing is that it runs inside the model. It's there is NMS post-process. It's embedded in the model. So really, we don't really need a lot to do. We will have an output which has pretty much everything we need. So number of classes 80, number of bounding boxes per class 100. So which means we are really close to the standard model. This model usually has 8,400 detections, and here we have 8,000 detections candidates. Inside, you can follow here we are following the Livebook in the Victoria's NxHailo repo. So here is the vision resize and pad. This is basically what in my library, my YOLO library, is the frame scaler. This is the kind of frame scaler for the vision resize and pad. Let's see what this is. So we save this. So this is a function to resize an image and a vision matte, and the target age and target date. These are the same because the target W, so we have usually in YOLO models we have same width and high. All right, and so yeah, this adds padding, resizes the image, and adds padding when needed. Usually the padding color is this type of gray. Okay, so let's load an image. I have here London traffic. So London traffic. Okay. So remember that we are connected. This code is running on our Raspberry Pi. So a vision, mread, Kino, fs, email, fast. File path. This is London traffic. It should be a JPEG. Yeah. So we have car track, because this is a model to trained on the Coco dataset. So we have people, probably is going to detect cars, truck, bikes, motorbikes, people. Let's see, and traffic lights maybe. Let's see. I actually don't know how it runs. This model runs on this image. So Matt. But the thing is, this image is 1020p. So we need to resize it, and we're going to use this function here, vision resize and pad. Okay, whoop. Matt. So I think this should be the height and width of our image, right? Yes. So let's use matte shape. We need 720 is the high. So original high orange width. We don't need the channels shape, and then we need to pass the original width. First the high and second the width. Orange width, and then the target is 640 by 640. Okay, and this should be it. You see that this function adds the padding, all right, and resizes to 640 by 640. So we have the right input. So let's call it padded or matte, okay? Padded image. And so we now need an input tensor. So we need to convert this image to an NX tensor. So we run a vision matte to NX, and then we need to transfer the tensor to the NX backend. Here I'm running, I think it's XLA, so let's see. So this is padded matte. Okay, and NX default backend. Oh yeah, it's binary backend. Because, yeah, I need to set okay, here we need to set the XLA backend. So NX XLA backend. Okay. Okay, and all right, so let's rerun everything. Let's see if the tensor is then transferred to the XLA backend. NX default backend, great. Okay, now we have the input tensor, and we don't need any pre-processing. Let's go inside the code. So we're going to use this infer. So this infer encodes the input and then runs the inference on the Hailo device and then parses the output. So let's see. I have my notes here. So we are going to run the inference, and the inference is this. And I'm just following here. You see the this Livebook. I'm changing the things, but I'm running this inference here, and let's see in detail what this function does. So the inference, so we pass the Hailo model we have loaded before. Then we need this name here. And actually, I'm going to get this from here. So we see that inside the Hailo model, inside pipeline Hailo model, so we see that we have an input vstream infos and output vstream infos, okay? So what we need to pass to the inference function, we need to pass this input name, because I think that the reason is because we could have many names. Same for the output, we can have many input layers, and we could have many output layers. Output layers for sure, because I use that feature with the Hailo input maybe. So the reason is we need to say to the model, okay, and to the library, okay, I want this, okay, I want YOLOv8 input layer, so it's going to be this, and model shape, which is going to be this, meaning with 640 by 640, 3 channels, 3 features. And then the output key is, again, it's the name is this one. So the output is YOLOv8 NMS post-process, okay? So if we run, so if we pattern match this, if we run this, we pass the input tensor. We don't need any pre-processing. It's good as it is. I think the reason why you see here that there is no, this is the output, but here the input, we don't need to quantize it because it's already quantized. I mean, the input is 3 channels of 640 by 640, unsigned integers, 1 byte, numbers between 0 and 255. These are RGB values. So they're already good as they are. All right, so name, input, and then we have a parser. A parser, this is part of the NX library, and this is the parser YOLOv8, and we will need something different for YOLOx. You see parse, so because the output will be in this case, actually I think it's in this case is a float 32, okay, but it doesn't need to be dequantized. And here you see that the input is unsigned int 8, okay. So this is the reason why here it's parsing. So the output is a binary, and the library returns the inference returns. You see here the inference here. These results. It's a binary. Actually, is I think it's a map with the key matching this key here. This key here, and then the value is a binary. And the binary needs to be parsed based on the information of the output. So in this case, it's a float. We don't need to dequantize, and yeah. So we run the parser, and here is basically converting the binary to a list of floats, and then the list of floats is converted to let me see here, parse list. Parse list, it's converted to Yeah, directly, without even passing to NX. So it's converted to a list of detected, row detected object. This is a internal strat of NxHailo. All right, so let's see. So classes, oh yeah. Classes, we need to pass the classes. These are the labels, and key is the output key, meaning this is the output name. Let me load the classes. Where do I have the classes? Here. So on this, again, the prev I don't need because it's already defined. The classes, we read the classes from here, just in the code. Yeah, okay. Yeah, so we have our list of objects, but they need to be denormalized. You see that these numbers are relative to the width and height of the input image. But you see that truck, car. Is there a person? Yeah. So, and the score is the confidence class ID. So great. It seems that it works based on the objects we have in the image, and we need to post-process. So we need to post-process. You see here, we should have a post-process function. Post-process. Yeah. Post-process, we pass the detected objects and the input shape. Yeah, I guess this is the original. So this is the original shape. And so do we have row detected objects? Okay, so NxHailo, parsers, YOLOv8, process, input shape. Is this, let me see again, I forgot, it's this high and width. Okay, so it's original high, 720, original width, because it needs to scale. I think it needs to first to scale those floats to the 640 by 640, and then scale considering the padding. This is what the image scaler does in my YOLO library. Yeah. Okay, pretty cool. Let's see if okay. So here it's using the coordinates are converted to xmin, xmax, xmin, xmax, so ymin, ymax. Originally, YOLO Ultralytics YOLO outputs the center coordinates xy and then width and height. I don't know if this model compile outputs this type of coordinates. Yeah, it seems so. But okay, so now we need to filter. So we want just the objects that are with filter before. So filter only the objects for which the score is higher or equal than 25%. Wow, oh yeah. Okay. So detected objects. Now we need to draw the, and the cool thing is inside the so this is a YOLO draw version for eVision. So let's copy this from and pass it here and see if I need to change anything. I don't think so. it should work out of the box. Oh yeah, I don't want this frame per second label right now because we are not going to run it in real time. So let's remove the label, but if you want to keep it, just copy and paste it and just pass like an empty string, but or with something written like FPS or something. But yeah, so this is the full width. We don't need this. Whoops, we don't need this as FPS bar. You know, I'm going to keep it just for simplicity. So yeah. So I can show you what you need to do to run it without thinking too much of updating the code. And let's close this. All right. And YOLO, how is it called? YOLO draw. Yeah. So YOLO draw detected object. So this is the original. I don't know if it's the original mat or the one with padding. Let's see the original one. Detected object. Oh yeah, because we passed the original shape. So detected objects are these. Detected objects. And yeah, FPS. And here we are. I don't know if it's, yeah, so car. Unbelievable is able, I don't know if you can see it, but so person is able to get all these cars, track, is able to get this person. I don't know if it's on a bike. Let me see here. I can't even understand honestly. Well, if it's a person or not. Maybe, I don't know. But yeah, this is a person for sure. So works pretty well.